Hello everybody, we are now come to the video clip number 9 of this chapter 3. Okay, this is a pretty long chapter, so we still have a lot of video clip for you to watch and learn. So for this clip, we are going to talk about the so-called derivative and the integrals of the vector function. So don't forget that your vector function, okay, depends on one input t, but the output will be depends on your dimension of the vector that you study. For example, if we study the three-dimensional vector, you got ft, gt, and ht, or sometimes if you have only two dimension, so we can have the ft or gt. Okay, so what is the derivative of this vector function? Actually, the derivative is the same old definition. Okay, we can use this notation dr by dt, or you can use r prime, because this time the only input is the t, so we can just use the prime to indicate the derivative. And it is the change, right? The change of your r, okay, which is the r when you plug in t plus h minus your r when you plug in t, over that change h, and then you let your h goes to 0. So that's the same old definition. And because you know how to find the limit of the vector function, which is the limit of each one of them, right? Then it is pretty easy that your r prime will be your f prime, g prime, and h prime. So it is the derivative of each component, okay? And it will be the same, it will represent the same thing as in your calculus 1. Okay, so as you got a curve, remember, as you got a curve in calculus 1, you have your curve just like this, and then you are finding a derivative at some particular point here, let's say. Then the derivative at this particular point actually represent the slope of the tangent line, okay, of the straight line that is tangent to this curve at that particular point, right? So this is the same thing. So if you want to find a derivative at this particular point, okay, so the derivative at this point will be a tangent vector. Now it's a tangent vector, okay, instead of the line, it's a tangent vector to the curve r t at that particular point t that we consider. Okay, so let us go to some of the example just like this, very easy. So your r is a t cube, and then this one, and then the cosine. Okay, so what is it again? One problem in terms of derivative of the vector function becomes 3 problems, okay, for the derivative of your calculus 1, right? So the first component, you got 3t squared. The second component, you need to use the product rule. So this is the first derivative of the second plus the second derivative of the first, which is 1. And then the cosine, you got -5, and then sine of 5t. Okay, and you can, you know, simplify a bit, or you can just leave it like that, it doesn't matter. Okay, so you got this one, this is 5t, sorry. Okay, so that's the derivative. Now if you need to find a unit tangent vector, so as I told you, the tangent vector, it just simply your r prime, here the tangent vector, at a particular point that we consider. So right now the particular point that we consider is the point t equals to 0. So that's the same problem, right? So what we just did is your r prime at the arbitrary t, it is 3t squared, and what else? It is e to the -t 1 minus t, and it is -5 sine of 5t. So you replace your t by 0. So you got 0, you got a 1, right? And you got a 0. Okay, so this one is actually a tangent vector of your r at the point t equals to 0. But if you need to find a unit tangent vector, you just finding the length of your r prime together with your r prime, right? So it's 1 over the length and then this one. But it happened that this vector got the length of 1, right? And your r prime. So it's just the same thing. So this is a unit tangent vector to this curve at the point t equals to 0. Okay. Next, let us look at the other example here. Okay. So you want to find a parametric equations for the tangent line. Okay. So it is actually the equation of the line, right, to the helix with a parametric equation like this. Okay, so this one sometimes called a parametric equation, and it is the same as your vector equation as cosine t, 2 sine t, and then t. Okay, please keep in mind that this one is different from the previous helix that we just did, that it is a circular helix, right? But this one is an elliptic helix like this. Okay, so to find the tangent line, what is it that we need? We need the point that it passing through, okay, which is given here, and it is a typo, so let me just change to be this point. And then you need the parallel vector. Okay, and the parallel vector now is a vector that must be tangent, so it is the same as your r prime t at a particular point t that you're considering. So of course it must be at this point. However, this point is not really a t, right? It's not really the input for your vector function. So you need to determine the t for this particular point, okay, that generate these three components. And as you look at your r, okay, you should be able to see the last one, the last term is t. So the last term, of course, determine the t immediately, right? So your t must be pi over 2. And if your t is pi over 2, let us check a little bit. As you plug in, your sine of pi over 2 is 1. So you got a 2. And then as you plug in here, your cosine of pi over 2 is 0. So you got really this particular point. Okay. So this means that you can go ahead and find your r prime t, okay, for the tangent vector. So you got a negative sine t, 2 cosine t, and 1. And you need this tangent vector at the particular point t equals to pi over 2. So the sine of pi over 2 is 1, so you got negative 1. The cosine of pi over 2, it is 0. And the last one has no t to insert, so you got a 1 right there. So this is a parallel vector. So the equation of the tangent line that you need, and it must be in terms of parametric. So it is the x equals to the point that passing through plus the vector t, y equals to the point plus the vector t, and z equals to the point plus the vector t. Or you can say that this is x equals to negative t, y equals to 2, and z equals to pi over 2 plus t. Okay, so this is the parametric equation of your tangent line to this helix at this particular point. Okay, you may try to do it yourself. Okay, if you want to find the same thing, the tangent line, but at t equals to pi, what will happen? Okay, you can try. All right. And of course, there'll be a lot of different differentiation rules, and usually all the rule it is the same old thing as your function of real value. For example, if you got two two vectors, now these two vector added together like this, you can just separate it and find a derivative at each one of them, and then you add them up. If you got a constant in front of your vector, so now the constant is called scalar, you can pull out the scalar and go ahead finding the derivative of the u. If you got a function, so this is the scalar function multiplied with the vector, so it's just the same old thing that you can use a product rule. The first derivative of the second plus the second derivative of the first. Okay, but if you got two of the vector, finding the dot product u dot v like this, again you can use the product rule, but now your product is a dot product, so it is the first, okay, dot with the derivative of the second, and the second dot with the derivative of the first. And for these two things, I mean, you can switch any order. Okay, you can switch in any order. However, this one for the cross product, okay, it has to be in this order. You cannot switch. Okay, it has to be the first one derivative cross the second, and the first one cross the second derivative. It must be like this. You cannot switch your order. Okay, the only thing that you can switch is the addition. Okay, but the cross product, I mean, you need to start with the first one derivative, end up with the second one derivative, just like that. And one more thing is that if you got your u and you have a function inside, so this one is the chain rule, right? So it is a derivative of your vector u and then multiplied by a derivative of the one function inside, as we got in the same old chain rule. So let us look at some of the problem, but all these problem is something that you deal with all the properties that we have learned. Okay, so for example, this one you need to show that the derivative of these two vectors crossing each other, so it is the r and r prime, then the result only survive one term. It's okay. So let us look at the property that we emphasize. Okay, so this one is the one that you cannot switch the order, right? So you have to got your first one derivative, so this is your left hand side, cross your second one, but your second one happen to be r prime, plus your first cross your second one derivative, so from your r prime you got r double prime. Okay, this is your left hand side. However, I mean, you may need to recall yourself that if you got u cross product with itself, it always goes to a zero vector. So this one equals to a zero vector plus r cross your r double prime. So of course it is your r cross your r double prime that is survive. So it is your right hand side. Okay, so this is very simple, but you really need to have the right order. Okay, next, if we would like to show that the derivative of the length of your r, it is this one, and of course your r cannot be a zero vector, otherwise we cannot have this length. Okay, so you need to recall that the length of your vector u is actually a u dot u, and then take a square root. Now we have a derivative with respect to t of the r dot rt dot rt, okay, raised to the power 1/2. So you have 1/2, and the rt dot RT raised to the power negative 1/2 is look just like the chain rule, right? And then a derivative of the one inside. Okay, so you are going to use the product rule, but this one is the product rule in terms of a dot product. Okay, and this RT dot RT raised to the power negative 1/2, you use this one again, so you got 1/2, and then the length of RT, and this derivative is just simply the first derivative of the second dotted plus the second, and it happened to be the same derivative of the first, so they look pretty much the same. Of course they can combine, so these two will cancel, so you are going to have RT dot R prime T over the length of RT, just like this. So let's look at the next concept. The next concept is simply the integral, okay? And the integral, of course, it is only the definite integral of the continuous vector function. So it will be in terms of the integration from a to b of your vector RT with respect to t, and it's simply as the derivative or the limit, okay, it's just the integral of each of the components, okay, just like that. So again, one question in this chapter becomes 3 problems in calculus 1, and that's it. Okay, so for example, if your function given as a cosine negative t I side of 2t and then t, you need to find the integral from 0 to pi over 2 of this vector function. So first what you have to do is to find an integration of each and every component. So look at the first component, you are going to find the cosine, but because of this negative, so don't forget that the integration of the cosine becomes just simply a sine of negative t, but because of that negative, so you have another negative out, right? So you are evaluating from power 2 to 0. So as you plug in power 2, you got a side of negative power 2 and then minus 0, and the side of the negative power 2 is simply negative 1, so you got a 1 out of it. Next, we can find the second integration, which is 0 to pi over 2 of sine 2t dt, okay, and the integration of the sine, you got negative cosine, but because of these two, you have 2 divided here, so it is evaluated from power 2 to 0. So if you plug in pi over 2, you got a cosine of pi minus a cosine of 0. So what you end up with, cosine of pi, it is negative 1, and cosine of 0 is 1. So you have negative 2 inside, and you still have a negative 1/2 outside, so you got a 1 out of it. And the last one we can just write here, because it is only the integration from 0 to power 2 of the t dt. So you have t squared over 2 from 0 to pi over 2, and it's simply pi squared over 8, okay, minus 0. So that's the last one. So this means that in conclusion, the integration from 0 to pi over 2 of the RT dt is just simply the first term is 1, the second component is 1, and the third component is pi over 2, pi squared over 8, okay, just like that. Very simple, but you really need to know how to perform integration using your calculus 1, right, on each of the component. Okay, so let us stop this video clip over here, because right now you guys know how to find the derivative of the vector function, you guys know how to find the integration of the vector function. So we will see you later for some other concept about the vector function. All right, so see you then. Bye bye.